All right. So what I would like to do is just kind of review what we talked about as far as reactions yesterday. Specifically, I want to go through single replacement today. And you have to have your activity series to do that. So let me put this on the board for you guys. Okay. So yesterday we saw that in a single replacement reaction, you have two things, you have two reactants. One of them is a single element or a diatomic, and then you have some kind of a compound. And that single element is going to try and replace part of that compound. So as a review, you have three different types. There's a metal replacing a metal, meaning that the single element is a metal and the element in the compound is also a metal. Okay, so in this case, lithium would try and replace sodium, and you would have to look at your activity series to see if that would go through. So that's a metal replacing a metal. If you have a halogen replacing a halogen, your single element is a halogen. Most of those are going to be diatomics. Not most, all of them are diatomics. And then you can only replace the second part of that compound, the halogen part. So chlorine and bromine, look at your activity series. If it works, it will go into this side. Okay. Halogen replacing a halogen. And then lastly, metal replacing hydrogen. And that's when you have a single element as your metal. And now hydrogen is involved in your compound. And it's the hydrogen that really is, you have to pay attention to how that hydrogen is given to you. It's not as simple as just looking at, oh, it's a hydrogen, this is how we're going to go. The symbols that come after the hydrogen are going to be very important because how that hydrogen represents itself, it's either going to be in an acid or it's going to be in water. And if it's an acid, you're going to always see AQ after it. So that's going to be an acid because this has been dissolved in water to make it an acid. So you'll see AQ. If it's water, you're either going to see an L for liquid or G for gas. And that also makes a difference in what form your water is in. So hydrogen's a little bit more finicky about how it is in that compound and what all of that looks like. So what I'm going to have you guys do, I'm going to bring up the activity series and I want to explain how this works. So the elements in your activity series, and you can look at your paper that I just passed out to you. The elements that are at the top, okay, those are your most reactive elements. And then as you trend down, those are becoming less and less reactive. So in this case, lithium is your most reactive metal. And as you go down, AU, gold is your least reactive metal. So I think that it's, if you look at the little lines beside it, that's why I want to do these up here. So that very first line says displace hydrogen from acids. So I want you to draw a little line under lead. Okay, that's kind of where that cutoff is. So that means that anything from the top, so lithium, all the way down to lead, that can replace a hydrogen if it's in an acid. Okay, so if you see that hydrogen involved, and we just saw like HCl was AQ, if that's how that was involved, that hydrogen's involved in an acid, then any one of these can replace it. And you'll know that it can replace it because if you have an element that is higher on the list than the one it's trying to replace, it can go ahead and do that. So only your more reactive metals can replace your lesser reactive ones. So in this case, anything below hydrogen, copper, mercury, silver, platinum, gold, none of these can replace hydrogen because they're all below it. Only the ones above can replace ones below, not the other way around. So when I talk about looking at your activity series, I'm asking you to look at the list. If it's higher on the list and you're going to be looking at your single element only, is that single element higher? If it is, it'll replace it. If it's not, it doesn't have enough strength to replace it. It's less reactive. Okay, so pretty much everything from lithium on down to lead can replace hydrogen in an acid. Okay, the next line says displace hydrogen from steam. So now water is going to matter whether it's in liquid form or if it's in gas form. So that line, I think on your paper it looks like it ends at iron, but it actually ends at cadmium. So draw a line underneath cadmium to that second line there. That means anything from lithium to cadmium can replace that hydrogen if it's water, and that water has to be in a gas form. So again, how your hydrogen is given to you is going to matter. So everything on down to lead can replace hydrogen no matter what. Everything on down to cadmium can replace both acid and water if the water is in steam form. And then if the water is not in steam form, if it's just regular liquid water, then you have that cutoff at sodium. So you can draw a line underneath sodium. That is going to be the cutoff. So only those first 4 or 5 elements, it's 5 on here, it's 4 on your paper, but only those elements can replace the hydrogen in water. So if you have a single replacement and you're trying to figure out, will it happen? If you have a hydrogen, pay attention to if it's an acid, if it's a gas, or if it's a liquid, because that's going to dictate whether it can be replaced or whether it can't be. Okay. So the other thing I want you to write down, it's not on here, but you also have halogens. Okay. And technically, if you don't want to write it down, as long as you remember your halogens go in order of your periodic table. So fluorine is your most reactive, followed by chlorine, bromine, and iodine. So those go in order of the periodic table. So even if you don't have your halogens on here, so if you were to use this on a test and you're like, well, shoot, I don't remember. Well, it just goes in the order that they're already in your table. So fluorine is the most reactive halogen, followed by chlorine, bromine, and iodine. Okay, so fluorine can replace all of those. Chlorine can only replace bromine and iodine. Bromine can only replace iodine, and iodine can't replace anything. So again, it can only be replacing things that are below it, not above it. So you'll always have to refer to this list right here, so that if you are trying to predict the type, what's on the other side of it, you can figure out if it is going to replace it or not. Okay, so let's do a couple examples here, and then I'm going to have you guys do some practice. So let's just do a couple examples. I'll just do it on the board. All right, so let's start off with Mg plus HCl. So first of all, how would you know that this is a single replacement reaction? Because now you don't have the reactant or the products to identify what type it is. But when you have a single replacement reaction, you always have one single or diatomic and a compound. So a single and a compound is kind of going to tip you off that it's a single replacement. So now the next question you ask yourself is, what is my single element, or what's my diatomic here? So in this case, magnesium. So magnesium is going to be doing the replacing. So if I have magnesium, and what's it going to try and replace? H or Cl? H, right? It can only replace H. Magnesium is a positive. It's going to be a positive. And in a compound, this one would also be your positive. So positives only replace positives. So it's going to try and replace the H. So now you have to pay attention to, how is the H given to you? Okay. If it doesn't say AQ after it, it doesn't matter, because how do you figure out if it's an acid? Well, it's not water. So if it's not water, it's an acid. So in this case, I don't have water, so I have an acid. So magnesium is going to try and replace hydrogen in an acid. So this is where you go to your table and you look and you say, okay, where is magnesium? And then where is that hydrogen? So magnesium is 1, 2, 3, 4, 5, 6th one down. So can magnesium replace hydrogen? Yeah. So what it's going to do now is it's going to do that. It's going to replace hydrogen. So now Mg is with Cl, and now H is by itself. Okay? But there's a lot of problems with this now. So what do I have to do with Mg and Cl? Can I just leave it just like this? I mean, you could, but it would be very, very wrong. If you put this on a test, I will mark it wrong. Because Mg is a what charge? Positive 2. What is Cl? It's in group 7, so -1 charge. It's okay. We're all tired. So if Mg is +2 and Cl is -1, what's my compound here? MgCl2. So again, when you're putting things together, when you're creating your products, please make sure that you're putting them in a way that balances out ionic charges. Okay? And can I leave H as H? No, why not? What? It's a diatomic. Yeah, I'd have to put H too. Okay? So it's knowing those little things about remembering what your diatomics are, putting ionic compounds together. So that is a single replacement reaction. Magnesium and hydrogen flip-flopped. So those are things that you want to pay attention to. When you flip-flop them, Is it something that needs to be kind of reconfigured as far as your charges go for ionic bonds? Is your single element a diatomic? If it is, make sure you write that down. If it's not, then just leave it alone. Okay, am I done with this? No, why not? It's not balanced. Yeah, it's not balanced. Our good old friend balancing is going to be very much a part of this. So what do I do? Because I have only, what are the two that are not balanced? Hydrogen and chlorine. And this is an easy one to balance. If I've got 2 chlorine and 2 hydrogen here, what can I do here? There you go. So Mg plus 2HCl gives you MgCl2 plus H2. That would be your final completed, here's my single replacement reaction. Okay? That makes sense? Okay. Now let's do another one. Let's do... All right, now let's do Na plus H2O in liquid form. Okay, Na plus H2O in liquid form. Okay, so which one is my going to be doing the replacing? Na, and what's it going to try and replace? An H. But look, H2O is a little bit confusing. Does it replace one H? Does it replace both H's? How does this work? I want you from here on out, when you guys are looking at H2O, I want you to think of H2O as HOH. HOH. Because when you think about it that way, it makes more sense to have the Na and the H flip-flop, because if this gets taken away, what are you left with? OH. So Na is really going to be bonded to what? OH, if that goes through. So think about H2O as HOH. And that'll kind of help you determine when that first H is going to get replaced, what are you left with at the end? It's a little bit harder to visualize that when you just see H2O. Okay, so can sodium replace hydrogen in liquid form? Yes, it can. It's the last one that can. Okay, anything below that wouldn't be able to do that. So let's go ahead and do that. So Na is now going to be bonded to what? OH, what's going to be by itself? H, yeah, this H got kicked out. So, and then H is going to be H2. Okay, is NaOH okay as far as your charges go for that one? Yes. +1, -1, so that one's okay. So, is this balanced? It's not balanced because my H's, I have 2 on the left-hand side, but I have 3 on the right-hand side. Okay, so what do you want to do? Here's what I'm going to recommend. And again, this is where kind of balancing you'll pick up little tips and tricks. I know that I am probably going to have to put something here because there's only one oxygen here. Or I'm sorry, one hydrogen here. So no matter how many I put here, plus one more is going to make it odd. So I know I'm going to have to put something here just to make this even. So let's just try a 2. So if I put a 2 there, how many total hydrogen would I have? 4. Okay, so I could put, bless you, I could put a 2 here to make that one a 4, right? That also balanced out my 2 oxygen that I just created. And then what do I need to do to figure out this one? Yeah, so 2, 2, 2, and then just 1. Okay? So those are single replacement reactions in which you have to look to see, does it replace? Let's do one more. Let's do a metal replacing a metal. Okay, so I have gold plus magnesium chloride, Au plus MgCl2. So what's going to be doing my replacing? Yeah, Au is going to try and replace Mg. Can it? Why? So in this case, I have gold as my replacer. But gold is the last one on your list. It's the least reactive metal. So can I actually have gold replace magnesium? No. So does anything happen with this? No. So you write Nr. No reaction. Because there is no reaction that can occur because gold is not strong enough to replace magnesium because it is much less reactive. So if you ever come across two reactants that cannot replace each other, you just write NR and you move on because there's nothing that happens. Okay? You have to use your activity series every single time. Pay attention to the hydrogens because the hydrogens are the one that are kind of the pain to figure out. Other than that, questions on single replacement? Okay, you have some time to practice this.